Hello everyone, today I'm going to explain the problem 49. In this problem asks us to use a shift register and additional logic to design a logic circuit of the sequence detector described in the state diagram below. So first, let us look at the state diagram. As you can see, the output is written in each state. So this is a Moore machine. In a Moore machine, the output depends only on the current state, not directly on the input. And next, I will explain the meaning of each state. State 0 means that no consecutive one has been detected yet. If the input is 0, the circuit stays in state 0. If the input is 1, the circuit moves to state 1. State 1 means that one consecutive one has been detected. If next input is 1, the circuit will move to the state 2. If the next input is 0, the sequence is interrupted, so the circuit will return back to the state 0. State 2 means that two consecutive ones have been detected. If next input is 1, then the circuit has detected 3 consecutive ones, so it moves to state 3. If the next input is 0, so the sequence is interrupted, so it returns back to the state 0. State 3 means that the target sequence has been detected, since the output of state 3 is 1. This state represents successful detection. If the next input is still 1, the circuit will remain in state 3 because there are still at least 3 consecutive ones. If the next input becomes 0, the sequence is interrupted, so the circuit will return back to the state 0. Therefore, from the state diagram, our target sequence will be 3 consecutive 1. And next, I will explain the shift register circuit. Because the problem asks us to use a shift register, so I used 3 D flip-flop to build a 3-bit shift register. And let's call the serial input X. The 3 flip-flop outputs are labeled as Q0, Q1, and Q2. And the connection is D0 equal X, D1 equal Q0, D2 equal Q1. This means that the input X goes into the first flip-flop, and the output of the first flip-flop goes into the second flip-flop, and the output of the second flip-flop goes into the third flip-flop. And at every clock edge, all D flip-flop updates at the same time. So the next state equation are the Q0 equal X, and Q1 next equal Q0, Q2 next equal Q1. Therefore, after each clock edge, Q0 store newest input bit, Q1 store the input bit from the 1 clock cycle ago, and Q2 store the input bit from 2 clock cycles ago. So the 3 outputs, Q2, Q1, and Q0 represent the most recent 3 input bit. And now we need additional logic. Since the target sequence is 3 consecutive 1, therefore we can use a 3 input AND gate. The output equation is Z equal Q1 and Q2 and Q1 and Q0. So when Q2, Q1, and Q0 are all equals to 1, the output Z becomes to 1. If any one of them is 0, then output Z will become 0. So the complete circuit is a 3-bit shift register plus a 3 input gate. And next, I will use this table to verify the operation of the circuit is right. At the beginning, after the reset, the flip-flop are all clear to 0. So we have Q2, Q1, Q0 to be 0, 0, 0, and output is 0. And starting from 0, 0, 0, if the input sequence is 1, 1, 1, the shift register change from 0, 0, 0 to 0, 0, 1 to 0, 1, 1, and finally becomes 1, 1, 1. At this moment, the AND gate output is 1. If the next input becomes 0, the sequence will be 1, 1, 0 because it contains a 0 inside, so the output will become 0. Until next 3 consecutive ones input, the output will be 1 again. If the next input continue to be 1, because it contains at least 3 ones inside, so the output is still 1. So we use a shift register and additional logic to design a logic circuit of a sequence detector. What problem need us to do? Thank you for your listening.